Chapter 3, talking about matter. It's a small chapter, and many of you will appreciate that there's really no math in this chapter. So hold your cheering to a minimum. Matter. Matter is anything that occupies space and has mass. Matter exists in 3 different states: a solid, liquid, or gas. And we encounter things in these different states. The air that we're breathing is in the gas state. The water in your water bottle that you're drinking is a liquid. The chair that you're sitting on, thankfully, is solid. And those are the 3 states that matter can exist in. I thought I got rid of the animations in this, but I didn't. Yes, question? What about plasma? Good question. There is a 4th state of matter, and it's called a plasma, and it's a very, very strange state of matter, and we're not going to talk about it in this class, because there are plasmas that occur naturally, but they're very, very rare, and so we can just overlook that. That's the beauty of Chem 10. We can just skip over a lot of stuff. It's like, you know what, that's too complicated. We're not going to talk about that. But yes, there is a 4th state of matter. So let's look at these different states and see what makes them different. So we're going to look at water, because water is a compound that we are familiar with in all 3 of its states. And there are very few compounds that we experience in our everyday life in all 3 states. When water is in the solid state, we have a special name for it. We call it ice. So here's an illustration of some ice cubes in an Erlenmeyer flask. And here we have a diagram. It would be really cool if we could just zoom in and look at what the particles are doing. But they're too small for that, and so we have to draw pictures instead. But here's drawing a picture as if we could zoom in and look at what's going on in there. And here we see that there are individual molecules of water, and they're arranged in this pattern. It's kind of an open pattern. And that's what ice does. That's what water does when it freezes. It makes these patterns. These particles, the molecules, are not moving relative to each other. This molecule and this molecule are staying next to each other. A little bit like you guys in your seats right now. You're not moving around the room. Everybody's stationary. You're sitting in your seat. But are you sitting perfectly still? No. Everyone is at least breathing. Okay, I don't see anybody sleeping yet, but that's because it's early. But, you know, you're fidgeting, you're looking around, maybe you're taking notes. You're moving a little bit. The particles in a solid are moving. They're vibrating, they're oscillating, but they do not move relative to each other. In a liquid state, the particles are still close together, but now they're moving around. And this would be like students in lab, where everybody's walking about. It feels like you're milling about. You know, it's a small room, there's a lot of people, we're milling about. We're all close together, but we're moving relative to each other. And that's what liquids do. In the gas state, the particles are now very far apart from each other. They are not touchingly close anymore. There's a lot of space between them. And they're just going off in different directions. They're just completely independent of each other. The gas state of students is when class is over and we open the door and whoosh, people go off. And you go off in all kinds of different directions, and some of you go to different towns. And you maybe don't see each other at all until the next time we come together. And that's what gases do. So let's examine these 3 different states of matter individually. Kind of talked about them already, but just kind of to summarize. Solids are rigid. That means they retain their shape. They're not generally very flexible or anything like that. So a solid has a fixed volume and a fixed shape. Examples of solids: ice cubes, diamonds, iron bars. We can think of lots of examples of solids. Solids don't change their shapes when you put them in a different container. You take an ice cube out of the tray and you put it in a glass bowl. Does it change its shape? No, it still sits there, ice cube shaped, right? Does it change its volume? No. And then you could put it in a big pot. Volume and shape remain the same. Liquids. Liquids have definite volume, but they do not have a specific shape. If you take a cup of water and you pour it into a tall, skinny glass, the shape of the water changes. The volume of the water doesn't change. If you then pour it into a big pot, the shape changes again, and yet the volume stays the same. So liquids assume the shape of their container, but they retain their volume. They have definite volume. Examples: gasoline, water, alcohol, blood. These are all liquids. Here's just an illustration of how water takes on the shape of its container. Here somebody had some fun blowing glass, messing around with glassware, and we see that whatever crazy shape the container is, this blue liquid takes on that shape. Gases have no fixed volume and no fixed shape. So they take on the shape and the volume of their container. And taking on the volume of the container is the one that's just a little hard to think about sometimes, because it's hard to see gases. There are gases that are colored and visible, but we don't get to play with them because most of them are toxic. Excuse me. Whereas we've all played with water. You know, children, you play with water and you do stuff in the bathtub, and you're actually learning about what the liquid state does. Gases are hard to see and they're hard to play with, so we don't notice this. But a gas will occupy the entire volume of the container. And it can do this because its particles are so far apart. They're moving completely independently and they're going to spread out. Probably the closest thing to experiencing this would be with odors. Okay, what is a smell? You know, my kids, I don't know what they ate the other day, but they were letting some nasty ones. Okay, so 4-year-old in the corner passes gas, right? Does it stay over there? No, it spreads out and fills up the whole room. Now, it smells more strongly when it's concentrated, but something that's really potent smelling will eventually permeate the entire room. And that's, you know, we can tell, oh yeah, it got all the way over there, even though he was sitting over here when it happened, right? So the gas will fill the whole room. They take on the shape of the container and the volume. So air, helium, oxygen, those sorts of things are gases.